Yes, we can go. Cool. They stopped interviewing on the stage, and now I get this one. Cool. We only have 40 minutes, so I'm going to speed this up right away. Please verify that you're in the right talk, because if you don't care about Entity Framework Core, this talk is probably not going to be for you. Now, you've been warned. Clickbait is questionable content with the only purpose of making you click something, or in my case, making you come to my room. So welcome, you have been trapped. The content, usually quite questionable, not that shocking, waste of time. So you know what to expect of the next 40 minutes. Right. Who am I? I'm Hannes. I'm the father of 3 beautiful children and the fiancé of the mother of said children. I met her just across the bridge in Copenhagen, where I've also lived for a year. She's not from Copenhagen, she's Belgian, but at least you have a little bit of context why I love being here. I work at Access. At Access, I do many different things. They gave me the title of principal consultant. It usually means Hannes does whatever he wants, which is a great job. I can highly recommend that. I've also been doing .NET since 2005. And because I love doing this, sharing my knowledge with people on stages, I do have some community recognition as a Microsoft MVP and Service Bus champ. I also play a bit of music on stage, which you will get to see tomorrow night when we get on the stage out here with our band, The Linebreakers. So, plan for today, because we've got 40 minutes and I've already wasted one. So how's this going to go? How is these 40 minutes going to go? I'm going to present you 10 things that Entity Framework can do that I feel like are a little bit lesser known, but it could still be very useful when you're using EF Core. So I will just present the concepts. I'm not going to show you any code. Then you get to vote which demos you want to see. I don't have time to do 10 demos. I will probably have time to do maybe 2. So you get to vote which 2 you want to see. Then we do the demos. Then we run out of time. So I'm going to code a little bit, and then we wrap things up, right? So if you're feeling tired, I know it's the afternoon, pay attention for the first part, because that is where most of the content is. If you want to take a nap, you can do it during the live coding, and at the end there will be coffee in the hallway. Great. Are you ready for this? I got a chuckle out of Swedish people. I love that. That's great. So let's go. Number 1. Value type properties. Now, complex types have been a thing that we've had in Entity Framework since a very long time. We've already had it in Entity Framework proper, but now in EF Core, value type properties have evolved quite a bit, because I don't know if you notice, if you have some code and you represent it as a deep graph of objects, sometimes you want to map it as a sub-object and write it to some of the columns in your table. We've always been able to do that with complex types. Behind the scenes, Entity Framework used to always give this thing an ID. For its internal runtime, the ID could change between times that it was fetched, but the thing would be treated as a proper entity. Now, this has evolved quite a bit in more recent versions of EF Core, and we can do more things with it, and it actually works a lot faster and a lot more efficiently, and that's what value type properties are, right? Another thing that we often see, and I feel like it's from mapping databases to code in the way that you do things in the database, if you have 2 entities and you have a many-to-many relationship between the 2, if you want to do this in the database, what you usually have is you have some kind of mapping table. And that mapping table has a foreign key to the 2 primary keys of the 2 tables that you want to have that many-to-many between. So that mapping table is only doing the mapping of that many-to-many relationship. But in EF Core, we can basically map this without actually showing that table in code. We will just have 2 navigation properties for the many sites on the 2 thing, and the table behind it will be inferred from the fact that we are mapping that as such. Then I think this is a really cool one, hierarchical IDs. If you're using SQL Server as your database, SQL Server has support for mapping hierarchical data. Now, usually if you don't have this functionality, what you're usually going to do is you're going to have a self-referencing foreign key in your table. So what you usually do is the node points to the parent node, and then you will be able to fetch the data. Now, the problem with this is massively inefficient, because if you want to get all the children for a certain node, you're going to have recursive queries, and you're going to have many database round trips. It's not going to be pretty. It's not going to be fun. Now, hierarchical data actually has a solution to that. So what we will be doing instead of doing that is add a hierarchy ID column, which is a data type that exists in SQL Server. Now, Entity Framework can map this as well. And the cool thing is it enables you a whole bunch of cool querying in the tree structure. You can get all the parent nodes, or you can get all the child nodes, or you can get all the nodes at the same level. Like, you can do advanced querying on that tree structure. And if you're faced with data like this could be extremely useful to do that. Now, one of the reasons that I used to involve something else in my code next to Entity Framework was being able to run raw queries. Because, as you know, Entity Framework proper was kind of slow at times. EF Core has gotten a lot faster. So at some time, like on the hot pad of your code, sometimes you wanted to run an actual query instead of going through the whole DB set. Now, I used to combine Entity Framework with Dapper for that purpose, but Entity Framework Core now has the possibility to run raw queries into a database as well. So what that's going to look like is you have a SQL query literal in your code. It could be parameterized if you want that. We're going to actually run that through the DB context and execute it on our database. And what's going to come back is going to be materialized as objects. If you're familiar with Dapper, it looks almost identical and it can do almost the same thing. Now, maybe similar to the value types that we talked about, we can also do JSON columns now. And JSON columns are pretty cool. Again, same scenario. We have an entity. It has some nested data types in it. So it has some properties that are deeper on the graph. And we could take some of that and map it to a JSON column in our database. So instead of mapping all the properties of that nested type to all separate columns, we could just say, hey, let's map that to a single column and just put a JSON object in there. When is this useful? Well, this is obviously very useful if you have polymorphic data. If you don't know the exact type that you're going to have in runtime, it could be nice to be able to serialize this in a different way. That sort of stuff, using JSON columns for that could be very useful. And then batching. This has always been there, and you've probably already been using this, but it's not obvious if you've never looked at it. Now, a DB context, as you know, works as a unit of work. So you're going to be doing a whole bunch of operations. You could be adding, deleting, modifying data. And when you hit save changes, that is when everything gets executed on the actual database, right? So when that happens and you have a whole bunch of statements that need executing, Entity Framework is not going to execute them one by default. No, it's actually going to take batches and send them as a single block of statements, so it limits the amount of round trips that we get to the database. And that's a really nice performance issue. It's also something that you can tweak. You can increase your batch size or lower your batch size depending on the effect that you want to have. So if you're executing many rather small SQL statements, it could be beneficial to actually increase the batch size so that you have less batches that execute every time. Right. Has been around for a while. And this is a new one that's going to come in EF Core 10. It will be possible to connect a single DB context to two databases. So what we could basically do is we could take some of these DB sets and map them to one database, and then use a different connection string for the other DB sets. Now, the cool thing about doing this is that you can join across those sets very similarly as you would do with a single database. Obviously, all of that will happen in memory, but this is basically Microsoft's idea on how to do polyglot persistence. So we can query that, we can do our updates and all of that, we can join across that. Only like a transaction across all of the database engines is going to be a little bit more tricky to achieve. But it's basically, we could have a document database on one DB set and a relational one on the other, and that's going to be supported in the future. Inheritance. In code, us developers love using inheritance. We have parent entities and then we have deriving entities. And all of that works out really nicely in code. But when the time comes to actually save that data to a database, it might get a little bit tricky because there's basically 3 ways you can do this. The first way is to do it in a single table. And we call that table per hierarchy. We're going to save our entire hierarchy in a single table. But what we're going to need is we're going to have to put a lot of nullable columns in there. So what we will have is we have all the fields of the parent entity, and then all of the distinct fields of all of the child entities are going to be in there as well. And somewhere in there, we're going to have a column that tells us what type of records we are dealing with here. Is this a child number 2? Okay, then that is going to be in that discriminator column, so that when we fetch the data back, Entity Framework knows what to do and how to deserialize that row into an actual object. Another way of doing this is doing table per type. Table per type is where we have the same amount of tables as we have types in our type system in .NET. So we're going to give the parent entity its own table. We're going to have the child entities their own table. The whole clue to make all of this work is the primary keys are going to be also foreign keys that reference the parent table, the topmost table in the hierarchy, and that makes the whole thing work together. Now, the disadvantage of doing this is you'll get a lot of joins when you're querying, and joins is something that we should all be very afraid of because it's compute that we cannot distribute. It runs in our database engine. It's hard to move that compute somewhere else. And I usually try to shy away from this, but it looks a lot cleaner. For us developers, like the database looks like our code, and that's yay, it looks like the way that we are used to reasoning about this data. You could do something else to avoid a lot of the joins and avoid the discriminator stuff. If your parent entity, for instance, is an abstract class and you have a bunch of subclasses, you could opt for table per concrete class. And the thing with table per concrete class is for every class in our hierarchy, we are going to make a table that has the exact amount of fields. The tricky part of doing that is that we have to make sure that the IDs for all of these tables are unique across the tables. In previous versions of Entity Framework, that was a little bit tricky. Nowadays, it just generates a sequence that generates the primary keys across all of those tables. So if you generate this from your code, you're actually going to be good on that part. But they have to be unique across those tables, because if you get the same ID in the same DB set, Entity Framework is going to freak out and it's going to refuse to do work for you, which we don't want. We want it to work along, right? Something that we often encounter, and that is not a built-in feature, but that we can make work, is logical deletes. Because sometimes you want to have delete statements on your DB context, but you don't want to actually delete the data. What you want is the record to stay in the database, but the users cannot see it anymore. Now, the way to do this, if we have a deleted column on that database, we basically want to set that deleted flag to true. That's what we want to happen. Next time we query the data, we don't want to see that record anymore. If we combine a few features of Entity Framework, we can actually very easily make this work. We need shadow properties to hide that deleted column from the user so that it can exist in our database, but not in our model. We are going to need global query filters to filter out the records that have been set to deleted so that we're not seeing the records anymore. We're going to have to intercept on the save changes so that instead of actually deleting the entity, we're going to set that deleted flag to true, and we're going to set that record to modified and not deleted. So we're going to have a little bit of interaction with our change tracker to make all of this work. It's not as scary as it looks. It's a couple of neat features that you can combine. If you wrap this around an interface, let's say iLogical delete, that then it's doing that behind the scenes in your database, you could make sure that you just have to put that interface on your entities, and it'll work for every single one of them. It'll create that deleted field and so on. Takes a bit more work to do that than I can do in a demo, so I'm going to warn you, I'm not going to show all of that, but we can show that in the hallway if you really care. And I think we're at the last one already. One of the things that you can do is compiling your queries. Now, what is going to happen is Entity Framework operates in runtime. It's not the last one, there's one after this. If you compile your queries, if you run a link query, what Entity Framework is going to do, it's going to take your link expression and parse it into an expression tree. And that expression tree that gets analyzed, it gets converted into a SQL statement. And that SQL statement then gets executed on the database. And then we get results back, and those get materialized into objects, and we get results. Now, this parsing, most of the time, works really smoothly. Most of your queries are not that complex, but if you're doing very complex link expressions, that parsing might actually be hurting you, especially on code that is sitting on the hotpad of your application. So if you measure that certain queries are hurt by the fact that you're parsing them every time, you can basically do that parsing bit once. And then you have a parsed query. And then Entity Framework knows that if you're reusing this query, even if it is using different parameters, it can use the same parsed query. So all it needs to do is substitute the parameters in the resulting SQL query, and you can skip that whole parsing step on subsequent queries. This is very useful if you're performance tuning hotpots of applications where you have some Entity Framework sitting in the loop, because this is probably one of the first things, except for indexes and stuff, that you might need to do. And this is really the last one, I think, I believe. You don't need DB sets. I've been saying this for a long time. You could even do it in EF6. You don't need a DB set. A DB context basically needs a lot of info to operate. And the info that it needs, it usually derives from your code. It needs to look what your entities look like in code. It needs to look what your database tables look like. It needs to know how to map between those two things. It does not need to know these things at compile time. A lot of that is actually compiled at runtime. The first time you instantiate an instance of a certain type of DB context, that is when the on-model creating is going to do all of that work for us. It is going to derive from your code and all of your mapping and so on. Your entity type configurations is going to figure out what the code looks like and what the models in the database look like and how to map. So we could basically feed it all that info at runtime, even if we don't have a DB set. And we can use that set at will by using like a generic DB set with a type that we only know in runtime. Now, when is this useful to not have DB sets for certain types? Now, when you're building a certain type of application and you need to draw in types from plugins, you need to draw in types from derived entities, like all of that sort of stuff. You may want to complicate your own life and do some of this so that you're runtime feeding a lot of new information into that on-model creating. The tricky thing there is always making sure that your database is in the shape that your DB context expects it to be, because if certain columns are not there, it's definitely not going to work. We can still feed it information, but the database still needs to be in a certain shape to actually work, right? And I guess that was it. And I know I promised you nap time, but sorry. There's a twist. Oh shit, sorry, no, we're in Malmo, wrong building. So I've actually presented 11 and not 10. One of them is fake. So if I can work my way down the demo list to the fake one, I win, and you all owe me a drink. Great, because this is Sweden and drinking is expensive here, especially as a Belgian. Like drinks are very expensive in Sweden. So if I can work my way down the demo list to the fake one, you lose. Otherwise, we just make it to the end of the talk and we go and have some coffee, right? Take out your phones. You appear to be offline. Ha! Of course, because I rehearsed this at the hotel and not here. We can easily solve this. We do the open one, right? This one. Let's try this again. If you take out your phones and you scan the QR code on screen, you will be taken to Slido. And we will see a live refreshing list on the screen to see which demos that you would want me to do. You can track multiple things up there, if I remember correctly, and vote for the ones that you really like. I see 8 people still ranking, 5 people still ranking. We're getting there. Seems to be stabilizing. Okay, this looks like it has stabilized. Should I screenshot this? No, I probably don't need that. So, hierarchy IDs. Let me first explain to you how I'm going to do this in code. This looks rather small. So, with a bit of luck. How this solution works is I've set up simple console applications that have some code prepared in them. And they recreate their database whenever I run them. So when I'm modifying things, it'll just drop the database and recreate it so we can easily look at it. Never do that in production, okay? Your data, a second laugh from Sweets, great. Everything you modify on a database should be done by a pipeline, by a user who has DDL rights. It should not be your runtime connection string that changes the data structures in your database. Don't do that. Okay. Hierarchy. Let me show you quickly what this thing does. So we have some code at the bottom here. It just recreates it. It connects to a local DB connection string. Don't worry about any of that. What I'm doing here is I'm entering data. And I'm going to quickly explain where this data comes from. This is a demo from Microsoft themselves. So you have not picked a fake one, which is great. It's the entire Hobbit family, right? We start with Balbo as the patriarch, and then we go all the way down to all of the other nodes and all of the hobbits in the family. And your position in this hierarchy gets defined by the address of your parent and then the number of your own node under that parent. Right? So that mapping becomes important. If we look at Balbo, he's the root. If we look at Pasco, right in the middle there, that is node 3/2/1, and that is where we get to Pasco. And if we then want to query up, we get all the nodes that start with the first bit. If we want to query down, we want to get all the nodes that start with the node of the one that we're going from, right? Now, in order to make this work in code, I've added all these in code. So that's the thing that's happening here. So I'm doing an ensure deleted, ensure created. That just drops my DB context. And we will be doing some code here. Now, first of all, there is an additional package that I need to make this work. So if we look at our packages, you will see that there is a package called SQL Server Hierarchy ID. Now, because this is a SQL Server specific feature, this feature will only work with SQL Server, and you will need that additional package to make things work. Now, if we look at my entity, I've already prepared that to work the way. Is this code big enough for all of you to see, by the way? In the back? Sort of. You should tell me that. I'm here for you. You're not here for me. Well, you're letting me monologue for 40 minutes, so that's cool. But let me see if I can quickly increase the size. Because Control Scroll doesn't seem to be doing what I hoped it would do. It should be in window, right? No? view, obviously. Where is the size? It's normally Control Scroll, right? Control plus? No, it's not working along. Oh, there we go. Better? Yes, good. So if we look at I needed to scroll harder. I think that was the problem. The way that this works is you cannot use this as the primary key. That's a SQL Server limitation. So you cannot use the hierarchy as the primary key. It needs to be an additional thing that you have on the table, an additional column, which is why the hierarchy ID is there, right, as an extra property. You can make it unique if you want, so you can put constraints on it, but it cannot just not be the primary key. This is the path from Patriarch. So it's the path from our root node to get all the way from Balbo to where we are in this table. We just use that data type to set that column, and then it will make the correct SQL Server data type, as we will see in a moment. Now, the first thing that I'm going to do is I'm just going to set this to run the correct project, and I'm going to execute this, and this is going to crash. Because we need to enable this feature. So here we go. Let's see it crash for a second. We will get an exception. And obviously on those days that you're demoing, your laptop decides to be rather slow. Excuse me? Oh, the ID? No, the ID can be a GUID or whatever. Like, the ID doesn't matter. Like, this is a separate column inside the database. Now, this is the exception that I wanted to show you. The entity type hierarchy ID requires the primary key to be defined. So what Entity Framework now thinks is that hierarchy is just another entity, and I have mapped it as a relationship. That is not the case. I want this to map to the SQL Server hierarchy ID type. Now, in order for that to work, also this is weird that it complains about this, because this type comes from that hierarchy ID package. So unable to make that work, we have to feed into our DB context options the fact that we want to enable this feature. So if I go back to my code and I go to my DB context here, when I'm doing the options builder, this is something you probably are going to feed in from your application startup, where you configure your DB context. We're going to have to enable that. So all we have to do here is options.use SQL hierarchy ID. And obviously I don't have the namespace here. Oh, it's under the SQL Server. I'm sorry. It's not there, then I'm going to have to do this. There is another possibility to pass in an options from here when you're doing the use SQL Server. And that is the one where we can do opt.use hierarchy ID. That is coming from the package. This enables this, right? If we do that, it works. We get this column in our database. So I'm quickly going to run again so we can take a look at the database and see what we get after it regenerates and it recreates its tables. With a bit of luck, that should have gone a lot quicker now. Build succeeded. I think it's even already done running. So let's take a look at what we got here in the table. I know this is small again, right? Just scroll harder. No, it's not doing that. You'll have to trust me in the back. What we're seeing here is a couple of columns as we expect. The primary key is just like any other context table. What we're seeing here is we see the column for the path from Patriarch field, and it's of type hierarchy ID. So that's that SQL Server feature being used. If we look at the data inside that table, we can just get all of the data out there. No, not this. I'm at the database. Yeah, that's the problem, right? I need to be there. Okay. So you will see that data represented as binary in that field. So when we get this out, you will basically see that string. Should be able to zoom in on that, right? I have a solution. I'm just going to use my Windows UI scaling. And now the whole laptop is lagging. Great. See, this is the... You've seen Dylan Beatty this morning, maybe, right? Dylan Beatty has a rule about doing live demos, and we call it Beatty's Law. Beatty's Law says if the demo works, it could have been a video. If the demo doesn't work, it should have been a video. And in this talk, I totally violate that law, which is what's going on right now with me. But let's take the UI scaling display settings. That's going to be easier to deal with. And then everything will be big. I should have thought of that before. Let's just put this at 350. There we go. And now that will be a bit more readable as well. Cool. And as I said, now my laptop wants to act slow. Okay, so you see that it's saved as an encapsulated field in binary, but it is very much that hierarchy ID, that string that we saw in that tree that I showed you. Right. Now, what does this... oh, and now my dad texts me. Great. It's literally Beatty's Law. Every time I violate this, I get stuff like that happening. Now, what does this enable us to do in code? Because this is all nice and dandy, but I promised you that you could do cool stuff with this. Now, obviously, this is way too big now. We can query this in very different ways. So that node in the middle, POSCO, I've predefined that. And we can just parse a hierarchy ID from a string, and that will give us a position in that hierarchy. Now, what we can do is, if I want to get all my halflings here, I can use these hierarchies IDs in the where clauses. So I can basically say I want all of the parents or all of the children. So if I just take my halfling, and I'm going to say halfling.pad from patriarch, which is that field in my model. I can do something that says is descendant of, and I want to say that it's a descendant of POSCO. If I now run this, the output that I get is only going to be all the nodes that are underneath this one node in the middle. But the cool thing for that is that we're not doing it by doing multiple database round trips as we would have to do with a self-referencing foreign key. It's just a single query that gets executed and it uses the SQL Server feature. So I should have that output out here. No, not on the PowerShell. Yeah, that's crashing. Where is my output? Process. Oh yeah, they're there. Okay, it's just because I increased the size of everything. So the nodes that I'm expecting to see are there. They're being output nice and clean. If you would attach a profiler, you would see that it just uses that SQL query feature, and that is descendant of is actually something that you can also do inside SQL Server, and Entity Framework just translates that for you. Now, we can do more advanced stuff like this because there's another thing that we can work with, because this hierarchy ID also has the possibility to look at the level in the node that you can look at. So let's say that I only want to have the ones where the level is 3, for instance, and I execute that. Then we will see that we're only going to get a horizontal slice across that tree that we put into the database. Now, if you combine these two, you can combine it into queries like I only want the descendants of a certain node, and then I want them only to be of these levels, and you can very fine-grained go and look in that tree for the nodes that you're interested in. And I think that's very powerful when you're working with hierarchical data. Anybody have questions about this, or are we skipping to the next one? How much time we forgot? Like a little bit still, right? 6 minutes. What was the next one? Let me see. It was JSON, wasn't it? Was it compiled queries? Should be able to do that in 6. Famous last words, I know. Probably not compiled queries in 6. JSON was the third one, right? I can do that one in 6, if you still want to see it. Or we can run over time and do compiled. Who wants to run over? Those are the people who voted for compiled queries, right? Who wants to do JSON in 6? It's not really clear. So I'm going to make the executive's decision to make sure that I don't take your fika away from you and do the JSON one, because I'm pretty sure that I can do that one in less than 6 minutes. So here we go. We have another demo that is prepared just for this. Let me find it. The code that we're doing here, I'm going to show you the context first. So what I have is I have a shipment, and the shipment has a shipping address, and I've mapped that at the moment as an owned type, right? It owns one shipment, and the shipping label is a subtype of the shipment, and then the shipping address is a subtype of the shipping label. So I'm actually nesting 2 levels deep. And at the moment, I've configured all of this as owned types. So when we run this, I should swap to the correct project, obviously. Also, this is not the fake one, so you won. Great, you get coffee. If we look at what this generates, if we run it like this, we get into the database. That was demo number 5. Not to be confused with Mambo number 5 for people who are of my age. So what we get here in shipments is we get a lot of columns, and we can see the default behavior for complex types or for own types. It's adding the property and then even the nested property. So if we get into the shipping address on the shipping labels, you get shipping label, shipping address, street, house number, and so on, right? This is how it maps it naturally. Now, what I would want to do is have all of this into a single column that does JSON, right? And ideally, we would want that mapped nicely so that it works the way that we expect it. Now, to get this to work, you can use attributes, obviously, but I'm not a big fan of mapping code and attributes. I always use entity type configurations. So let's take a look at how we can do this. Now, we still need to get on the owns one of the top one that you want to map. So the bottom one, we're actually going to forget about. I'm not going to do this again for the furthest nested one. Only the top one that I want to save as JSON, that's the one I'm going to look at. And we still need to use that same owned type configuration, but we're going to need to have a little bit of configuration added to this owns one to make that work. And it's actually not that tricky, but we're going to have to use the builder. And the builder that we're using here, maybe I'm already using a builder. No, that's fine. So this is, as you can see, this is an owned type, owned navigation builder. And on the owned navigation builder, you can tell it how it should be constructing that owned type on the database side so that it knows how to map to this. So we can basically say on this builder, we can say to JSON. And basically that's all you really need. The only thing is now it's not gonna map the subtype yet. So if we want to take the subtype into this and draw that into the JSON, what we need to do is we need to do builder dot, and then again we work further from this one. So we do the owns one on that navigation builder, and then we can do here, this is our label that we are talking about. And the label is going to have, it's the shipping address. That is the nested property. So we do that in the as a nested structure now, but that makes sure that we draw that one into our JSON as well. So when we try to save an entity and I have the code that does that, I think it should be in this program.cs file. I'm actually saving a shipment with everything nested. That's our company address. It's not my home address, so don't worry. I'm not leaking any weird application, weird data that you're not supposed to see. There's still a compile error in there, isn't there? Yes. Semicolon. Not to be confused with the Greek question mark, which looks identical but does not compile. And what we will see now, I'm going to go back because I have faith that the code is going to succeed, but we're going to refresh what that table looks like. And what we're seeing now is we have a column that is of type nvarchar max with a little bit of extra work. If you use the column type mapping, you can actually map this to a JSON field in SQL Server as well. It just acts from the lowest common denominator and uses nvarchar max, but you can have a proper JSON field in there as well. And if we now select the data in there, what we are going to see is we have that JSON object sitting in there. We should even be able to visualize that if it's working with. Excuse me? Yeah, I'm doing that. I'm not double clicking hard enough, am I? Yeah, in any case, that is saved in there, and you already see the fact that if I drag this, you see the fact that the shipping address is nested in there, and you see all of it in there, right? And if you query this back, this behaves like an own type, so it gets fetched along. When you just fetch the entity, there is no includes that you have to write. All of it is there by default. You're going to get this back, and it makes it easy to work with maybe a little bit more sparse data or entities that have changing stuff in there. Good. Let me wrap up this talk because I lied to you and I'm sorry for that. So this was the coding time part of the talk. Any guesses to which one the fake one was? SQL query, multiple databases. Yeah, you should have taken your naps now. Obviously, it was multiple databases. There's no way that we want to go back to doing distributed transactions across multiple databases. This is never going to be a thing that we do. It's not a thing that we want. I told you which one was fake in the beginning. It was number 7. This is the 7th one that I presented, right? So thank you very much for coming to this talk. My name is Hannes. You can find me on Blue Sky, on LinkedIn. You can find courses. I have an 8-hour entity framework course, not about the funny stuff, but about all the useful stuff on DomeTrain. So if that is of interest to you, go on DomeTrain and watch that course. It covers most of the stuff that you're going to need to use entity framework core in production. So I hope you took at least something away from this. All I want you to remember, EF Core has become pretty awesome over the years. I've been using Entity Framework since the very first Entity Framework in .NET 3.5. It was a horrible, horrible abomination back then, and it was tremendously slow. It's not that anymore. I think you can cover most of your use cases nowadays with just Entity Framework Core, and I think that's the thing that we should be joyful about. I hope you have a fantastic rest of your Øredev. I hope you come and see us on stage tomorrow. If you have any questions, stick around, but I'm going to let the rest of you just exit and get your coffee and a bit of cake.